Hi everyone. It's my pleasure to introduce Dr. Dino Carpentras, a researcher in social complexity. Dino is currently a postdoc at ETH Zürich at the Department of Humanities, Social and Political Sciences, and a former, or maybe current even, Marie Curie Fellow, but before at the University of Limerick. His research is focused on concepts like social influence, trust, and crowd intelligence. To explore these concepts, he employs cutting-edge approaches such as agent-based modeling, belief network analysis, and item response theory. And today he's going to talk to us about some of these cutting-edge methodologies. So thank you, Dino, for joining us today.
Thank you very much again for inviting me and also for the amazing presentation. Yeah, I'm not a Marie Curie Fellow anymore. I moved to a new university, so I had to drop that. I'm going to share my screen so you can see. And okay, you should be able to see it, right?
Yes.
Okay. And yeah, thank you very much for the introduction. So actually, I can skip this part. Is mostly like I'm working on many different things, but today, if understood correctly, you were mostly interested in belief networks, so I will focus mostly on that. And in particularly, what I've been working on for quite some time, it was like a method which is called the resin, which I will explore, and then later I will also put it in the framework of belief systems. But what this method is doing actually is, again, this is a very super brief introduction, but it's taking your raw data, which contains some information about attitudes or opinions, and then it will produce what is called a spatial network. And we can analyze it both qualitatively, so just by looking at the network, because already this gives us actually quite some interesting information of the structure of the belief system. Again, I will explain everything later because this for you at the moment doesn't mean anything. And of course, like you can also explore it quantitatively. So for example, extracting some information about clustering, centrality, etc. Just to let you know, today I will talk about a lot about the qualitative side, mostly because it's much more intuitive. And but if you have any question, let me know, and we can go a little more into the quantitative side. So this can be applied to many different things. Now I can show you some application. Later I will have one of them more in detail. But again, if you have questions, I can explore many of them more in details. So one way we applied it to was to explore actually the attitude space regarding political attitudes. And so, again, you still don't know exactly what these graphs mean, but you can already tell that, for example, the belief system in Italy changed quite a lot from 2002 to 2012. And as we will see later, actually, this means like it became much more monodimensional, much more organized. This is actually what I will talk actually more in details. And this that a study we did on attitudes towards vaccination. It was before COVID, actually. And the properties of this graph, especially like this distance here, helped us actually in predicting behavior on vaccination. So it helped us understanding which countries would increase their vaccination rate and which countries actually would decrease their vaccination rate based on the structure of the belief systems on vaccination. Then you can analyze very fancy scenarios, like, for example, ternary systems, in which like you don't have to have a spectrum like left, right, but you can have also like system like Windows, Mac, Linux, in which you have 3 systems and you don't really have a central position. We explored this for how people evaluate other people based on their opinions. And then we also have very fancy analysis like on analyzing how scales work, or for example, on social media data. So I gave you a quick teaser just to show like what what is going to be about today, and also just to have a brief view of the kind of networks we are going to see. I'm going to talk much more in detail about the method, but what I want to do now is that I want to give you an introduction which explains actually how the method works, like how to read one of these graphs in a kind of intuitive way. And then later we can go like into all the mathematical details and see like how this works. But I want to do this now because I know that the attention of people actually fluctuates, of course. So I want you to be able to follow the applications, even if at a certain point your attention drops during all the details. So please bear with me with the naive introduction, and then you can you're much more free during when I start rambling about all the details. So the basic idea behind the method that I'm discussing today is that actually people have attitudes, but also that there is some connection between these attitudes. So if we ask people to some way connect these attitudes, people would tell you that actually supporting gay rights is connected to fighting climate change. And for example, supporting Donald Trump is connected to the idea of supporting the wall between United States and Mexico. Now, you can come up with many different theories of why this happens, but the approach we're taking here is that we can tell that two attitudes are connected because usually people who hold one of these attitudes also tend to hold the other attitude. It doesn't need to be always the case. It's just like there is some connection between these two. If you hold this one, you are more likely to hold this one than any of these other two attitudes. And this is the basic principle of raising. So the idea here is that if you have two attitudes, A and B, and they're always connected, so every time a person holds A, the same person will always also hold B, the algorithm, when analyzing the data, will recognize this, and so A and B would be strongly connected. So you will have a very strong link here, and also they will appear very close to each other, because we will have also a spatial component, which is going to be important. So for example, here, these actually were data about political data in the United States. And the blue one is actually the cluster of Democrats' attitudes, and the red one is the cluster of the Republican. What you can see is that all these attitudes are very well connected, as we would expect actually from Democrat attitudes. They're very well organized. If you have other attitudes like C and D, you can see that they tend to appear together, like in the first and the last case, but also in some cases they might not appear together. You will have that actually the connection between the two would be weaker. And so they will also appear as more separate to each other. So before we saw like it was a very pretty dense connection. Here we see like this big space between these two attitudes. So they're still connected, but the connection is way weaker. And finally, if you have attitudes which actually do not have any connection, also the algorithm will represent them as no connection between the two, and they will also appear very far apart. Again, I'm not telling you at the moment how this works, just to have a general idea of what it means, something like this graph. So it means that this attitude and this attitude actually tend to not appear together. If you select this attitude, you are very unlikely to select this one. And this in general generates some clusters and also generates this latent space in which you have the organization of different groups of attitudes. So these are simulated data. So this is why you have such clear clusters. But here what we were simulating was like three main groups of people: Democrat, neutral, and Republican. And what you can see is that actually you have the formation also of their beliefs. You have the Democrat attitudes cluster, the neutral, and the Republican. And you can see that actually also the distribution becomes much more linear. So it has like this horizontal organization in which you have that the Democrat are closer to the neutral and farther from the Republican. And this was it for the general understanding. So yes, like the main idea to remember here is that when you see clusters, attitudes very well packed together, it means that if you select one, you're very likely to select also the other one. While distance means that actually the connection is much more unlikely. Okay, so with that said, I can move now more into details, and eventually here your attention can also fluctuate. It shouldn't affect too much of the final result. It's just to have a better understanding of what is going on here and what is happening actually under the hood. So first of all, probably many of you are already familiar with network methods, but there is a very big family of different network methods. Just to clarify, there are a lot of methods which actually use people as nodes, like social network analysis. The type of methods that I'm discussing now take a completely different approach, because we are not interested in the connection between people. So if two people are friends on Facebook, but we are interested actually in the connection, in the structure of their belief systems, like how their attitudes can be organized, which kind of attitudes group together and which instead do not do that. The main branch of the literature actually in this field is called belief network analysis. And I will give you like a very quick introduction, because actually I don't want to talk about this too much, because it has many different limitations. And if you are really interested in attitudes, actually Raisin is better for some things. So as we will see, like belief network analysis is better for some particular problems, and Raisin is better for other. So the main idea between in belief network analysis is that you want to check the correlation of different items. So you take a survey, you take all the items, and you see like how well they correlate to each other. This, for example, was some work done by Buttiline and Vasey, who actually introduced the term of belief network analysis. And you can see that every node here is an item. So it's an entire question. And you can see like how well they correlate in the survey. This is very similar to correlation matrices, but actually people who use it like it because it gives you like a much more intuitive way to look at your survey. So you can have an overview of your survey and see already like which kind of items correlate well. But again, this is about items, while we will be much more interested in attitudes. And let me explain you better like what is the difference and what is the main limitation. So with belief network analysis, there are many different limitations that eventually you might overcome, but the biggest one that you cannot really overcome is that some way belief network analysis supposes that groups are symmetrical. And I can give you a very simple example. Let's suppose we have three items here, A, B, and C. And so this might be like gun control, immigration, and gay rights. We see they correlate. And so our interpretation of this network, usually we would have like bigger networks, but let's use a simple one for the example. The interpretation would be like that if you move towards the left wing, people would be, for example, positive and respond more positively to these items. And the more you move towards the right wing, people would be to respond more negatively about these items. Or eventually, like you can flip it depending on how the items are coded. But the important thing is like the more the left wing likes something, the more the right wings actually dislikes that something, and vice versa with this kind of networks. The problem is actually it might not be the case. So for example, we might have that Republicans might really love country music. Doesn't mean that Democrats need to hate country music. They might not have a favorite music genre. So we would like to be able to pick this in the network. The problem is belief network analysis doesn't really allow you to do this. So it would eventually either delete this extra nodes, or it will eventually add some phantom nodes. And here, in case like you're wondering, like, okay, is this really a problem or is just a minor effect? So here I'm showing you like 3 different networks that we analyzed, and I put a yellow bar in the center just to check if they're symmetric or not. And what you can see is that actually there is pretty much no symmetry. So the kind of information that we are throwing away is quite a lot. And as I will discuss later, we have an entire paper that actually is just based on this asymmetry here, because it allowed us to predict behavior of vaccination. So if you throw away this information, you're throwing away a lot of information. So how can we solve it? The idea is that in belief network, you want to look at the network of items. So you take each question and you check how they correlate to each other. For Raisin, what we wanted to do is to take an approach which is actually more inspired by item response theory. And so you don't want to look just at the entire item. You want to look at the item responses. So, for example, if you have an item on immigration, instead of having just one node for immigration, we want to have 3 nodes: one for people who answer positively on immigration, one for responses that are neutral on immigration, and one for the negative response on immigration. This is if your item actually has 3 levels. If it has 5 levels, you want like 5 different nodes. And within the code, this actually can be done by dummy coding each item. So you take an item and you dummy code it, so you produce as many new items as possibilities of responses. So for example, here I put a fictitious item on favorite food, and here you have like a new column which would be like all the people who responded that their favorite food was pizza, all the people who responded noodles, etc., etc. So the main idea is like, we don't want that a node represents an item, but we want that each node should represent an item response. So what is next? Like, what do we want to do with this with these nodes? Well, similarly to what has been done in belief network analysis, you might check the correlation between them. And so for some, you might have positive correlation. For some, you might have negative correlations, stronger correlation, weaker correlation, etc. As we will see, actually, at least in the graphical representation, we will usually only use the positive correlation. And we do this because actually we have an entire study which shows that the negative correlation is actually quite redundant, like it doesn't really add much information. And also just with the positive correlation, you can already have a good structure appearing, because as you can see here, the Democrat answers are connected to the neutral, but they're disconnected from the Republican. So you already have this organization here. Some way, even if we are distracting the ordinality, the algorithm, just by doing this, is able to retrieve the ordinality. And you can retrieve that actually the Democrat are more connected to the neutral than the Republican. And this is actually how we can have the appearance of this structure. And just to be clear, this is just classical correlation. So if every time you select one item, every time a person selects one item, also the same person selects the item response, also they select the other item responses. So you have a perfect matching pattern. You will have a correlation of 1. If they're mutually exclusive, you will have a correlation of -1. And if it is totally random, you will have a correlation of 0. So it's just a standard correlation. We're not using any fancy metrics here. Another interesting thing, and this might explain why actually you have so much more flexibility than belief network analysis, is because actually we also have much more information. So in belief network analysis, if you have 2 items, the amount of information you will have would be like 2 nodes and 1 link. for the same items in Raisin, you can have actually 6 nodes, 6 coordinates, and 7 links. And if you go actually to more realistic scenarios, you can have that here you have 62 links. Here we have more than 600. So this is like why you have so much more information and you can get actually much more flexible results. Of course, this might also be a drawback, because if you have like, you try to fit an entire data set, like you take the American National Election Survey and you don't do any cleaning and you just throw it into Raisin, you will have a massive amount of information. So it would be way too much and it would be very hard to understand what is going on. While with belief network analysis, eventually it might be easier to do something like this. So it's mostly like one gives you like a more distant look and the other one gives you like a more detailed look of the information. So I mentioned that there is also a spatial dimension, which is important. And indeed, Raisin actually is a spatial network. And if like you're not familiar with spatial networks, they are just standard networks, but every node has also a spatial component. It has some coordinates. And this, for example, is very important for airports, because let's say Washington, New York, and Paris are connected, but traveling from New York to Paris is very different than traveling from New York to Washington. Like the distance is completely different. So you want to have also this information in your network. In Raisin, we still have the spatial information, but here the spatial information actually allows you to see much better what is going on, because you don't need to look at all the connections between the nodes, but immediately just from the spatial distribution, you can tell that this cluster is actually very separate from the rest of the network, from the rest of the nodes. And the way we do this is that we just implement a force-directed algorithm, which is just an algorithm which will put together nodes which are strongly connected, and it will put farther apart nodes that are weakly connected or disconnected. So eventually you can think of this as a system in which like the nodes have some repulsion to each other, and the links actually acts as springs pulling the nodes together. And this is actually how Raisin works. This is like the entire process that actually allows you to have this clustering and latent space. So just with these processes, you have the formation of these structures. Now, a question that we asked at a certain point, it was like, okay, is this spatial distribution just a random spatial distribution, or is really like a latent space? Can we really make a claim that this is a latent space? And what we did, it was actually comparing this with item response theory. So I don't know how familiar you are, but I'm going to be very quick here, because I'm just going to give you like the main information on item response theory. And the idea is that you have a curve for every possible response option. So as mentioned before, in item response theory, you don't care about just the general item, but you want to care about the item responses. And in item response theory, this is modeled as a curves, but in Raisin, actually, we have the nodes. And so what we showed in the study was that actually the position of the nodes in Raisin correspond to the position of the curves in item response theory. Now, since they are curves, they don't have a position, but they have a mean. So what we showed is that actually the correspondence was between like the nodes and the mean of the curves in item response theory. We have an entire paper on this, and we showed this both with simulated data, so simulating some data from item response theory, and also using some real data. And we have that the two patterns actually are very straightforward. Like we have a very strong connection between the position of the nodes in RAISIN and the position of the curves in item response theory. This is to say that actually it makes sense to treat this space as a latent space. Let me also clarify something here. I'm not claiming that RAISIN is better than item response theory or belief network analysis. As mentioned before, every one of these actually is better at doing something. So if you want to develop a measurement scale, definitely you want to use item response theory. If you have like a massive data sets containing items from political items, everyday lifestyle items, etc., you want to use belief network analysis. If you want to explore a more confined attitude space and get information about, for example, the difference between left and right, or for example, pro-vaxxers and anti-vaxxers, RAISIN is probably the best candidate here. Okay, so probably I can just give you like a couple of applications, and then probably we can discuss. So the first thing that I like to show is that usually I was not showing this, but I noticed that after I was presenting many times, people were happy about this idea of visualizing ordinal scales, and so I decided to include it. And so we know that ordinal scales are ordinal, and you should not do a series of things like averaging them. And also we learned that, for example, the responses are not equally spaced, all these kind of things. What you can see with RAISIN, for example, this is actually data, we will discuss them more in detail in a moment, but these are data from the Wellcome Global Monitor, and it was data about vaccination. What you can see here is that actually the space between the responses is not equally distant. So you have that, for example, the very positive responses on vaccination are much farther apart than all the others. So for the first 4 levels, you have almost a uniform spacing, and then you have like a very big gap in the final step. So you can clearly see here the ordinal nature of the scale. And of course, if you try to calculate the mean, you can see that actually the mean here, it would be actually closer to mildly agree than it would be to neutral. So you would have these weird effects if you try to calculate the mean of this ordinal scale. So let's see now the more interesting result. And it's still connected to the data set on vaccination. So when we start studying this data set on vaccination, again, it was like a data set. It was before COVID started. It was data from 2018. And it has data from over 140 countries. The interesting thing is that when we analyze it, we were expecting some way the anti-vaxxers to be isolated from the rest of the system, because we thought of anti-vaxxers as extremists. And so we said, like, they're extremists, they should be at the extreme. They should be very far from the rest of the system. But as mentioned before, actually, the result we obtained was telling us exactly the opposite. So we were very surprised initially, and we thought if this was an artifact, because actually it was at the very beginning of RAISIN, so we didn't have all the mathematical structure that we have now. So what we did then was that we confirmed this with many different methods, for example, hierarchical clustering, and all these other methods actually showed that in some way you can cluster it in such a way that the pro-vaccine attitudes are the most separate from the rest of the system. And this actually gives us an idea, because regarding vaccination, there is a kind of paradox, which is that pro-vaxxers, in theory, they should have a lot of advantages, because actually they're the majority of people. Again, all this information were from before COVID. COVID actually was a very game changer. But even before COVID, actually, the pro-vaxxers were the majority of people, vaccines were supported by traditional media. They were supported by experts in communication, experts in virology, and there were already like some massive communication campaigns with massive budget, which were promoting vaccination and were trying to fight vaccine hesitancy. For example, here you can see like in 2019, again, before COVID, the World Health Organization declared vaccine hesitancy one of the 10 threats to global health. And so the kind of mystery here is that even if anti-vaxxers have all these disadvantages, some way they're still better at converting, like there are some studies which show that they're better at some way converting the neutral on their side. And so why is that? Well, what this data is showing, and especially knowing that this is a latent space, this data is showing that some way like the neutral are closer in this latent space to strong distrust, so to the anti-vaxxers, than to the pro-vaxxers. And these are actually the aggregated data for the world, but even if you go like country by country, you can see that in many countries, you have this distance. Of course, like depending on the countries, you can have like bigger or smaller distance. So we were wondering, like, can these explain actually why the anti-vaxxers are so good at converting the neutrals? And so we run many different simulations of opinion dynamics, which are kind of agent-based models, which are used to simulate social influence. Here we use many different models because these models are still very simple and they have a very weak connection with the real world. So we didn't want our result to be due to some specific artifact of a model. So we tested here 5 different models in 4 different configurations. And you can see that actually in all these configurations, the model predicts that actually the prediction of the model and the prediction we have from from raising from this distance actually are in quite good agreement. They have a correlation which ranges between 0.56 and 0.29, I think. Yeah. Anyway, no, 27, I think is the minimum. Anyway, they're all very strongly significant. So also the model makes predictions which are coherent with raising. And by the way, we didn't fed the model with the data, the data from raising. We just give the raw data to each model and we make the prediction. We made the prediction also with raising, and then we compare the two, and we compare if they correlate or not. So the theory seems to say that actually this ideological distance is quite important for predicting the influence of the pro-vaxxers on the neutrals. But what are the data saying? And so actually we did also some work on, we take also like the real world data, and we had data on vaccination coverage and on trust in vaccines. Since the models are dynamic, actually, we didn't compare the data of 2018 with the data of 2018, but we wanted to make a prediction over the following year. So actually, the information of vaccination coverage and trust in vaccines are from 2019. So we're making a prediction on the following year. And also in this case, actually, we have significant predictions. And just to give you an idea if these numbers are big or small, another very strong prediction in vaccination is trust in vaccines. And the correlation between like trusting vaccines and vaccinating your children has been shown to be between 0.2 and 0.4. So actually, we are in the range of one of the strongest predictor. And this is actually because we are talking about a phenomenon which is happening at a very big scale, and it might have influence of many different things, because if just a politician says something about vaccination, this would have like a pretty strong effect. So we're not claiming that this actually predicts everything, this is a part of what is happening, of course, in the social landscape. So just to conclude, the last thing we studied in this case was how policy can be done to avoid this problem. Because what we showed is that currently policy, since they know that the biggest predictor is trust, what policy are doing is that they want to promote trust in vaccination, of course. But the problem is that while promoting trust in vaccination, you might go and change the structure of the belief system. So what you might do by mistake, because like actually you don't know what is going on under the hood, if you're not doing this this properly, what you can do is that you can promote trust in vaccines while pushing actually this cluster even farther apart. So what will happen then would be that immediately you have a boost in vaccination because a lot of more people trust vaccines. But then you are in this case of low influence, so the pro-vaxxers are not able to influence anymore the neutral. And so while you have an immediate increase in vaccination, in the following years, actually, you will have a decrease in vaccination because more and more of these people would be influenced by the anti-vaxxers. And so you will have a lot of an increase of anti-vaxxers in your population. So yeah, what we showed is that if you want to do like this kind of policy of promoting trust in vaccination, you need to be careful and look actually at the belief system, because you can do it properly. And so actually you can do it in such a way that you even increase the connection between the pro-vaxxers and the neutral. But if you do it improperly, you will have the other effect. And so some way like all your effort would be useless, because after a couple of years, you will be back where you started from. And just to give you an example, like, could you study all of this with other methods? Yes and no, because for example, with belief network analysis, you don't have this information. So the entire study couldn't be done with belief network analysis because you just have the correlation between items. You don't have any information of this distance here. And with item response theory, the problem is that you have even more information, so it becomes much harder than to get anything. So eventually you can extract it from item response theory, but the problem is you have so much information that you cannot see it all at a glance what is happening. While here, for example, just by naked eye, you can immediately see that there is a big gap here. And yeah, so this is pretty much like what I've been working on. This is Raisin. We have, if you're interested, we have a website with some tutorial. We just yesterday, actually, we published our R tutorial. So we had it in Python. Now we also have it in R. So if you're interested, you can check it out. There is also much more information. Like if you feel very nerdy, you want to explore all the details, you can do it. There is much more material there. And I also want to thank actually the other two people working on this, Adrian and Philip, which actually helped very a lot with this kind of research. And yeah, that's it. I think I'm, yeah, exactly 40 minutes. So, and yeah, if you have any question, let me know.
Thank you so much. That's really interesting. And I think we already have some hands up. So Dawn.
Yeah, thank you. Yeah, that was fascinating. Thank you so much. So one clarification question first, which is that your projection that you showed us, which is really cool, that's based on, you said it's based on the strength of the link. So is this the strength of the correlation between two response items for different variables? So for example, you gave the example of the vaccine data set. What would be like the two, could you give an example of what the correlations are here? Okay, so it depends. It really depends on the
on the data set and many things. If I remember correctly, because I don't have it here, but I think like the correlation in this group was about 0.6, 0.7, and it becomes weaker and weaker in this direction. You can also see from the fact that actually is more expanded, but you can have also quite weak correlations. So eventually,
yes, yeah. Sorry, what I meant was correlation between what, as in not the value of it, but the what are you correlating here?
Oh, it's the responses. So what you are doing is that, for example, you have two items, and you have like one item is, for example, do you think vaccines are important for children? And then you break it down into multiple answers. So you dummy code it. And so you will have a node for each one of these responses. So for example, one node here might be vaccines are important to children, strongly agree. Another one here might be vaccines are important to children, mildly agree. This is neutral, mildly disagree, strongly disagree. And you generate like these columns, which are dummy coded. So now they are in 1, 0 or true, false. And then you calculate the correlation between these columns. So for example, here you would have the correlation between vaccines are important to children, strongly agree, and I don't know, vaccines are safe, strongly agree. And this would be the correlation between the two.
Okay, so it's not two different variables. I think, okay, I have a bit of confusion there because wouldn't one person only select one answer? So how
No, it's actually, it would be like on different variables. It's so here you will have the same response level onto different variables. So one is vaccine are important to children. We can do it also maybe like, you know, gay right and gun control. You can have gay rights strongly agree, gun control strongly agree, and you calculate this correlation.
Okay, so there are actually two different questions, and then it's
yes.
Okay, right, that was the
yes. Like you skip it. Like I didn't explain it this because it's extra details, but you skip it between items coming from the same. Sorry, responses coming from the same item. So actually, I can show it. Way too many slides. So, for example, here, you see, like you have the first line. The first line is gay rights, and you have like agree, neutral, disagree, and the second one is immigration, agree, neutral, disagree. It doesn't make sense to calculate the correlation between these and these because are actually on the same, they're mutually exclusive, so you cannot really calculate this. At least like if you know that your survey is mutually exclusive, eventually you can have some surveys in which you can select multiple answers. In that case, it might make sense to select, to calculate the correlation between them. But in this specific case, it doesn't make any sense. So yeah, you drop the correlation between them and you just calculate correlation between responses of the first item and the responses of the second item.
Okay, perfect. Yeah. So having clarified that, I was interested in what you said about the mean being very different from when you see the sort of graphs and where the mean ought to be. But doesn't the mean really reflect the sort of proportion of people and where they are as well? So aren't we looking at?
Sorry, can you speak a little louder because I didn't hear most of the question.
Sorry.
Yeah.
So you talked about the mean being different from the sort of proportion, from the latent space and the distance between items. So that would be the correlation, right? So I think what I was getting at is that you kind of need to look at the means of both variables there to really be able to compare. And also, I think it's probably looking at two different things, am I right? Like, so because your mean is a reflection of the proportion of people who are in that position.
Okay, wait, I think you're talking about item response theory, because actually all of this, like we don't calculate the mean of anything.
Yeah.
The only case in which you use the mean it was like to compare the position of these nodes to the position of item response theory.
Yes, what I was talking about was the slide where you showed the distance and saying that the mean doesn't reflect the distance between the nodes. And I agree that, yes, of course, the mean doesn't reflect those distances, but it seems to be that we're comparing two different things here, because the mean of any sort of scale is going to is a function of
I see what you
how
mean.
many people pick that. So I think they're both useful information, but I just wanted to make sure I had the classifications, like, sorry,
you were talking to this
conceptualization. Yeah, so because that's the right slide.
Okay, I see. Now, so what I was saying here is that, you know, there is this thing that they tell you, like, you should not calculate the mean of ordinal scales. Again, it depends on because if you're calculating the mean, what people are doing, it's a different thing. But for example, if you take, you know, you have half of the people who selected strongly disagree, half of the people who selected strongly agree. You average them and you say, like, the average answer some way is neutral. Some people would be okay with that. Many people would complain because you are averaging an ordinal scale. So, and here I'm showing that actually, in some cases, you can clearly see that an ordinal scale, averaging an ordinal scale, is problematic because you might have uneven spacing. So you can still claim that the average should be the neutral, but if you go in the latent space, actually the average would be like closer to mildly agree.
I suppose I sort of, maybe I'm coming from it from a different perspective, where I would want to look at the distribution of people along those responses, and maybe that's a different conceptualization, which is why I'm trying to clarify.
No, you can also like try and look, but what I was talking about is just like, you know, there is this thing like you should not average ordinal scales. It's just like it's taught many cases, like, and many times actually is passed on very quickly. So yes, in cases like you can just look at the distribution, you can do many different things. So I don't know, it depends on your study. So this is a very general claim, and case by case, actually, the type of analysis you're going to run will depend on actually what you want to do with the data.
Yeah, okay. I think, yeah, we could probably discuss a lot more because this is really interesting, but Simon's had his hand up for a while, so
okay.
let him go.
Yeah, Simon.
Thank you. Yeah, first of all, thank you. That was a fascinating talk. My question is, when we look at one of the Raisin charts, so perhaps the one that you had up just now, which for the vaccine attitudes, is it meaningful to ask what is on the y-axis? So where those nodes are, if I take two of the red nodes on the left, I understand what's on the x-axis is basically your trust scale, but what's on the y-axis?
Okay, this is a very good question. So it should be another latent variable, but we're still studying that. Like, we have some preliminary results that if you really have two strong variables, so you have quite a lot of variability, they compare very well with like 2 dimensions. So you will have like a latent variable on the x-axis and another latent variable on the y-axis, but it still needs more studies. So I would say like it's another latent variable, but I wouldn't take it so, I wouldn't be so quickly to implement it, especially like in cases where you have like little variability, because I don't know exactly what, how you can classify this. But another way to look at it is mostly like to check like how clustered it is. So you can say, you know, let's say the simplest claim that you can make without going into claiming that this is a new latent variable. You can just say that, for example, this group here is much more clustered than the other group. And of course, you can see it by naked eye, but you can also like double check it with quantitative measurements of like the average connection between like this cluster and this cluster.
Thank you. I suppose another way of asking kind of the same question is when you have two nodes and you're establishing the connection between them, I understand that the distance between them is determined by the relationship, but what would make the line not horizontal?
So you mean like what would increase like the spreading, like what we see here? Yeah, it would be, I think like you can analyze from different perspectives. Like one would be like if you have another variable, another latent variable, because actually, yeah, it will increase the spreading because you will have that these nodes do not cluster anymore that well, even if like their position on the x-axis is kind of fixed, but they don't cluster anymore that well because there is also another dimension there. And so like they spread much more. Since they can spread only on the y-axis, they will spread on the y-axis. So this is representative of a new dimension. Eventually, if you don't want to buy the argument of latent variables and dimensions, you can just say that they're less coherent some way. So the fact that you see like the spreading in this direction, it means that some way like the anti-vaxxers are not so compact as the pro-vaxxers. So this means that here, if you select a strongly pro-vaccine answer, you're extremely likely to select all the other ones. With the anti-vaxxers, actually, this is more weakly. Like if you select one of these, you're kind of likely to select this, but you might also select this or this with higher probabilities. While with the pro-vaxxers, actually, you have this very compact structure. So I don't know if I really answered your question, but to me, it's mostly like when it's expanded, it's mostly like lower structuring or coherence, whatever we want to call it.
Thank you. No, that makes sense. Thank you.
Yeah, thanks. I got a question. So I assume that the distance, right, as we see here, is basically some sort of a measure of the degree of polarization.
Do you want me to directly answer, or you're still present?
Yeah, let's start with that.
So the short answer would be yes and no, because it is some form of polarization, but it's a different form of polarization to, like actually polarization is a very broad term. I think the most classical one is just the fact that you have the distribution of two groups and the Democrat and the Republican, for example, and you can show like how distant they are. This is mostly like a kind of polarization intended as how well structured are some items, like the responses. So you can have like this kind of separation. You can interpret it as a polarization, but it doesn't mean to be exactly the same thing as the two distributions are going farther apart. So you can still have, for example, I showed at the beginning, like the ternary system, for example, like in some way, I would say this system is very polarized because you have very well-organized structures here, but it's a ternary system. So can you still consider it polarized? And in the usual sense in which you need a single axis, it doesn't really make sense to call it polarization. But in this sense, where you see like how well organized are the belief systems, actually, yes, it makes sense to talk about polarization.
Yeah, so the follow-up question would be if you can come back to the slide where you show that if you introduce some sort of intervention, you might actually result in the
like it
it
might
backfire. Like, yeah, that one. So so following up on that, like because this is something that we do here, right? We do try to come up with some sort of interventions that either about the spread of disinformation or polarization or so on. And I was wondering how we could apply the logic behind making this network-based attitude space in trying to understand how well does our interventions work. So if you can expand on that.
Yeah, no, actually on this one, actually I was quite quick. So I didn't really explain how you can see this working. But the main idea here is that actually you have connection, for example, between the strong trust and the weak trust, because you have people in between. So you have people who can hold like one attitude here and one attitude here. So the more people some way cross these two groups, the more these two groups would be well connected. Well, if you have that people are either here or here, these two groups actually would be very disconnected. So what you want to check is that if you're increasing the number of people who strongly trust vaccination, you still want quite some people in between, because these people are your intermediary. So let's suppose I'm neutral on vaccination and or any topic, and there is a guy who says like, oh, this, like, you really need to trust vaccination because there are plenty of articles, it's safe, etc. The problem is, like, we might have too much distance to be able to talk to each other. So some way, like, I cannot see things from his point of view because there's a quite big ideological distance. However, if I'm used to talk to people in the population who are kind of in between the two, these kind of people can help a lot because they can act as a kind of in between, and so they can some way they will feel the influence of the pro-vaxxers because now they're closer to the pro-vaxxers, but they can also exert some influence on me, while a direct pro-vaxxers won't be able to directly influence me. And for example, this is what's happening here because between the anti-vaxxers and the neutral, there is a lot of steps in between. There are a lot of people who hold like one strong distrust, one neutral, one part distrust. And so there are a lot of people in between, which eventually, like, if they come to talk, they will find something to agree on. While if you take a neutral and a strongly pro-vaccine, they will have very little to agree on. So you really need someone in between which can act as a kind of intermediary. So the problem is, like, if you do this kind of policy and you just boost vaccination, what might happen is that you increase this population, but you get rid of all people in between because they are actually the easiest to convince. Because if someone is already like in quite good agreement with vaccination, you can just boost it a little more and they would belong to the green group. But the problem is, like, if you put like all the people in between in the green group, then you will increase the isolation. And so then you will have pretty much no one to influence the neutral anymore. I don't know, is it clear or?
Yeah, I still need to wrap my head around it, but I think it is. Dawn is raising her hand, though we don't have a lot of time. So Dawn,
okay.
If it's quick.
Sorry, I was just saying, yeah, that's very, very clear. Thank you. I think there's maybe I just put a bit of a challenge to the assumption that because you're very much in the green group, that you're unable to connect with people who may be questioning. And it's very good news that there is that sort of spread apart nature in the sort of strong distrust group, because it does seem to show that they're a bit open to hearing. And I say this because having come quite soon from a workshop in which someone who was very much in the green group was showing us his success in talking to people in those sorts of red groups. So I think it's not a given that just because you would score on attitude surveys and so on high in the green group, that there's no possibility to connect with those on the other side. I think that's really what you're talking about, right? Like to sort of like maybe put the policy efforts into finding ways that those who have strong trust can connect with those who have strong distrust, for example.
Yeah, no, I think it's very important. Like this is actually what would be like very important, because a lot of policy is done to some way top down, but what we were focusing here is that actually other people are very important to convince the neutral, for example. Like you can try to think always top down, so we need more advertisement of trust in vaccines, but actually just the other people who already believe vaccination is important might help you a lot. But to help you, actually, we need to put the right environment. And what this is showing is that actually you need some people in between, because we have what we can call polarization a lot here. And so we have this kind of division between who trusts in vaccination and who doesn't. Of course, it changes from country to country, and also like after COVID, the landscape changed a lot. But what we need in many cases is some people in between that actually can help in bringing the influence of the pro-vaxxers to the neutral some way. And so like improving the dialogue.
Yeah, absolutely. I guess I just question whether we need to do that while also reducing the levels of trust of the people who already trust it.
Wait, you mean like removing?
Yeah, we don't want them. Yeah, we don't want the
the
green people to become less trusting, to be able to talk to.
This is a good point. I don't know. It's quite a risky point to make. So the way we simulated, but we thought about it. But what we simulated was not like pushing some of the green people down, but we tried to push everyone up in a way that will increase this bonding. So having more people, let's say, in between here, but like pushing from the left side more than to the right side. Eventually you can do it, but that's kind of a risky move. So it's dangerous zone.
Yeah, and with that, I'm afraid we have to wrap up. So, Dino, thank you so much for joining us today.
Yeah, thank you very much for inviting me.
Yeah, and we